Hey guys, this is Mr. Wolf and welcome to the first flip lesson of College Prep Physics. Basically how this is going to work is I'm going to go through pages 19 and 22 of our notes. So kind of going through the notes part that we usually go over in class, but hopefully this will free up some time to work on the homework, quizzes, and go over questions that you guys have in class. And so one thing that I'm going to suggest for you guys is the best way for this to work is for you, as you guys are going through the online lecture, write down any questions that you guys have. And so the first thing that we'll do the next day is go over the questions that you had on this lecture. So we're going to be starting the second part of Unit 1, and it's going to be on linear motion, most specifically for this unit, constant motion. So here's target 4. You guys can look at the whole thing in your packet, and I'll be posting it in class, but I'm actually going to skip ahead to this slide, and this is really going to be breaking down target 4 in a way that's a little bit more easy to understand, and that is that there are 4 main ways to describe motion. The first is going to be using definitions or words, and the second is going to be using motion diagrams. And so the idea is that you could represent an object with this dot and see how it's moving through time, and we'll go more into that. Now the third is going to be using graphs. So by the end of this target, you guys will be able to look at a graph, and it might be position versus time. And you're going to be able to look at that graph and be able to describe the motion of that object just by looking at the graph. So finally, our last way of describing motion is by using relationships. And when I say that, I'm talking about formulas and equations to predict and solve problems. So the first term we're going to need to know is going to be distance. And distance is the amount of ground traveled. Pretty straightforward. Direction does not matter here. So distance must be a scalar quantity. Its basic unit is going to be the meter. So I know we use feet a lot in the United States, but when we're going to be doing any type of science, we're going to be using the metric system, so the meter. Our next term is going to be similar to distance, but very importantly different. So that's going to be displacement. So displacement is the change in position. That's what that triangle ahead of the D stands for. And displacement is the shortest length from start to finish. It may equal the distance if you travel in a straight path. And so an example of that, or when it wouldn't be in a straight path, is let's say we have a fly right here, right? And he's going to fly all around the room to this point right here. Right, the length of that path that he just flew, that's going to be his distance. That was the total amount that he traveled. Now our displacement is going to be from the start to finish. We just care where he started and where he ended at. We also care about the directions since it's a vector quantity. So we could say that he went from here to here, going this direction. We could say southeast. So direction is important. So displacement must be a vector quantity. All right, so this part I'm going to leave up to you guys. I just went over an example of distance and displacement, but on your packet, and I'm going to be checking this in class tomorrow, is come up with 2 of your own examples for distance and displacement. So our next term is going to be speed, and you know what? I'm actually going to first fast forward this to this part. That'll make more sense. So when we're describing motion in words, there are 4 possible word descriptions for motion. The first is going to be dealing with constant motion. So we've been talking about that. So when an object is in constant motion, it's either not moving or at a constant speed. And that's when, if you guys remember, our net force is going to be equal to 0. And sometimes it's difficult to think of something that's not moving being in constant motion, but if you think about it, let's say we have an object or a stone. It's at 0 meters per second at time 1. We check back maybe a minute later or 2 minutes later, and it's still rocking 0 meters per second. That's pretty consistent. That's pretty constant. That's a constant motion. So another way of describing motion, and this is going to be adding something new, is going to be changing motion. More specifically, saying something that is increasing its speed or decreasing its speed. If you guys remember from the first part of Unit 1, this is going to be when our net force is going to be greater than 0. So before I get to velocity, let's double back to speed. So speed is how fast an object travels. And any speed is going to be a scalar quantity. We just care about the magnitude. It describes how much distance is traveled in a certain amount of time. And a great example of speed would be that distance, miles per unit of time, hour. Although what we are going to be using most of the time is the meter, so our basic unit is going to be meters per second. And just skipping ahead, we've already gone over this. So velocity. So velocity is somewhat similar to speed, but they are different and in very important ways. So velocity is how fast an object travels and the direction that it is traveling. Any velocity is a vector quantity because it includes both magnitude and direction. Velocity describes how much displacement is traveled in an amount of time, and its basic unit is the meter per second. So similar to speed there. All right, so what's the difference between velocity and speed? All right, well, speed's going to be an average quantity while velocity is not. And velocity is a vector quantity. It contains information about the direction. Speed is often measured in miles per hour, while velocity is measured in meters per second. And since it's measured in meters per second, we're going to be using velocity a lot more in physics. Another reason we're going to be using it more is the concept of speed applies only to objects that are neither speeding up or slowing down, while velocity applies to every kind of motion. So it's a little bit more dynamic. We're going to be able to use it a lot more readily. So we're going to be using velocity more for that reason too. And finally, the last reason is speed is used to measure how fast an object is moving in a straight line, while velocity is used for objects moving along curved paths as well. So it's a little bit more dynamic, great for physics. So what I want you guys to do here is for this check for understanding is go back to those 4 ways of describing motion and fill out 1, 2, and 3 here. And I'll leave that up to you guys. All right, so motion diagrams. So hopefully I've talked about motion, I described motion diagrams in class today. The idea that an object's position is represented as a dot, and each dot represents a specific time interval. So let's go over a problem. How does the motion of object A differ from the motion of object B? Well, that first dot here and here, let's say that this is object A, this is object B. The first dot's going to be at 1 second. The second dot is going to be after 2 seconds, 3 seconds, 3 seconds. You guys get the picture. So there's equal time intervals between each dot, but the difference here is how much is the displacement. More distance was covered from here to here compared to the same amount of time. So what we have for A is a greater displacement over a period of time compared to B, where we still have that displacement, but it's a little bit smaller compared to that same unit of time. So we're going to say that A is traveling at a higher velocity. All right, it's traveling faster at a greater speed than object B. All right, so the last part of this video is on page 22. There's 2 word problems with constant motion. I want you guys just to work on those, see how you guys do. We'll do it for warm-up tomorrow. If you guys struggle with them, that's okay. I just want you guys to work them out. If you can't get an answer, just write questions that you have about a problem. Don't just say, I don't know. That won't count. Be a little bit more specific. Alright, so thanks for watching, guys. Make sure that you guys did fill out all of pages 19 through 22 in your packet. I'll be checking it tomorrow, and I look forward to seeing you guys tomorrow. Alright, bye.